Hello everybody, dear participants. I hope you can hear me well. Welcome and thank you for joining our webinar today on the subject CIO Plus and Stay Away areas. First, let me introduce myself. My name is Pavel Kaprichevsky and I have the role of the head of customer support department at 7Cs Chartwell Group. It is my pleasure today to moderate this webinar, and basically I will continue with our main expert for today for this event, Mr. Friedhelm Mogert-Kegler. He's now also on the video. Friedhelm's educational background is in geology and hydrography. He holds a degree in those two fields. He joined Chartwell Group in 2000, and since then he has held a whole spectrum of roles. At the moment, his area of responsibility is product strategies and solutions. So before I pass over to Friedhelm, let me briefly cover a couple of practical points that this is worth of having in mind for today's event. Questions can be addressed during the session using the questions section in that webinar tool that you're using. Some of them will be answered at the end of the webinar. The remaining questions will be handled after the session by email. This webinar will be recorded and later made available on our YouTube channel. Please note that the audience microphones will be muted at all times. And maybe finally, as an information, you can zoom in the presentation if you need to get a better display, or you can make the video smaller if you don't want to see Mr. Kegler in that big screen. You can make this option available using the webinar tool. So now we can get started, and I will hand over the stage to our expert, Mr. Friedhelm.
So thank you, Pavel, for the kind words of introduction. Yes, my name is Friedhelm Mogert-Kegler, and I also would like to welcome you to our webinar on Stay Away areas, Chartwell's new CIO Plus service. Good morning, good afternoon, good evening, wherever you are, and I suggest we get rolling. Okay, I just have to remove some of the windows here that are in the way, but now I think everything should be fine and you can hear me. Yes, our new data service, Stay Away areas, that's what I want to talk about today, or as we refer to it, detecting hidden shoals from space. So what does this mean for you? Today you will learn how the detection of shoals and underwater hazards in satellite images can be used to make navigation safer. And I guess that's part of our mission, that's part of Chartwell's mission. And so let's go into the details. This is an overview about the topics I'm going to talk about. So we will start with some background information about accuracy of bathymetric data in ENCs. We will elaborate a little bit on the role of the visual perspective, which means that it makes a difference from which angle or which perspective we look at things. We will do a very, very brief introduction of satellite-derived bathymetry, which is a technology which allows us to derive depth information from optical satellite images. But don't worry, I won't go too much into technical details here. We will look at a few grounding cases, and we did an analysis. And we're asking if Stay Away had been available, would it have been possible to avoid these groundings? Then we will introduce a new Chartwell service, CIO Plus Stay Away. And then there will be room for questions and answers. I think, I'm not sure if Pavel mentioned it, this is just the first part of a two-part webinar. So next week, there will be another webinar where we will more focus on the practical use of Stay Away on board. Today, I will provide you with background information, and let's go. Accuracy of bathymetric data in ENCs. I guess most of you will know that the accuracy of depth information in navigational charts can vary. There are still areas where the accuracy of depth information is poor, and there are areas where the accuracy of depth information is very good. There is a schema for the to encode and visualize the quality of depth information in ENCs. It's called the CATZOC. You probably heard or have seen the 6-character acronym that's typical for electronic navigational charts or for information in electronic navigational charts. CATZOC stands for Category of Zone of Confidence. And when this is visualized, the quality is visualized, there are these star symbols used. So many stars basically mean very good. Just a few stars mean not so good. So that's basically a simple way to interpret the quality of bathymetric data in ENCs. I'm not talking about clutter on the screen and that kind of stuff. That's not what we're talking about today. So why do we have all this different quality of depth information in electronic navigational charts? The quality mainly depends on the age and the accuracy of individual surveys. Remote areas tend to be surveyed less well and less frequently. Well, we can imagine if there are areas in your area of responsibility where you don't have any ships, where no ships are sailing, you would probably not send someone there doing costly and expensive hydrographic surveys. The mariners must take this into account. They must take into account the accuracy of the bathymetric data. And they must do this during route planning and also while they are sailing with ENCs in ECDIS. What I would like to draw your attention to, let's see if I can use this, oh, it works, this highlighting tool, that there's always, when we talk about accuracy, there's always a vertical component, a vertical uncertainty, and there's also a horizontal accuracy or uncertainty when we talk about accuracy of bathymetric data. We will come to this later. This will play a role in the course of the presentation. The importance of CATZOC. So when you look back, there have been several reports been published during the last couple of years that there are recent cases that have shown that obviously insufficient consideration of CATZOC has at least contributed to some of the groundings where we saw reports. Despite the fact that the data producers assign a low CATZOC value, there are cases where vessels tried to pass obstructions having an insufficient distance to do so. There's another issue, for example, the use of point symbols representing dangerous underwater obstructions led to wrong conclusions, and we have an example here. So basically, this is the symbol for an isolated danger. At this specific scale or at this specific range, this symbol would cover, in this example, 1,000 meters. If we zoom in, the same symbol would be much smaller, and all of a sudden, this circle of 1,000 meters exceeds the area that's covered by the symbol. So these kind of things also caused misinterpretations of how about the extent of the dangerous features. And evidently, mariners or some mariners tend to assume that digital data is more accurate than traditional paper charts. This is not always the case. Depends on how the digital data has been produced. So what I'm trying to say is that CATZOC plays an important role for various tasks that need to be executed during voyage planning and voyage monitoring. Let's have a look at the role of the visual perspective when it comes to the visibility of underwater obstructions. So in many cases, the groundings we analyzed occurred in regions with good visibility of the sea bottom. However, the visual perspective from the bridge of a vessel makes it difficult or even impossible to spot underwater rocks or reefs. Visible breakers caused by underwater obstructions are not necessarily distinguishable from normal overfalls and sea conditions. So we asked the question, would it have been possible, for instance, from a different perspective, to visually detect the shallow underwater obstruction? So if you look at this image, obviously when you look from above, it's much easier to see this obstruction as if you look at, probably not exactly the same area, but if you look from the bridge of your ship, you can imagine that there are situations where it's just not possible to see those obstructions. And even if you would see them, it would probably be too late anyway. What if we change the visual perspective? We think that shoals are more likely to become visible if the visual perspective changes. For example, if we use a bird's eye view, so we look from a specific, we look at an object from an elevation from high above. By means of satellite technology, pictures can be taken from space to generate aerial images at sub-meter resolution. And since the satellite cameras have a wider visible spectrum, they can detect items which are invisible to the human eye. So we have been involved in the past in research projects where we got in touch with such a technology, and there's a term called satellite-derived bathymetry, short SDB, which is a method to really determine depth information from satellite images. I'm not going into the technical details how this all works, but basically what happens is that you take optical images from a satellite. Cameras use a wider spectrum than what's visible to the human eyes. I mentioned it, and then there are algorithms and methods to derive the depth information. That's it with respect to the technical details at this stage. So we have a partner, EOMAP, where we did several projects together with EOMAP. They do all these processing. And what we've learned about SDB so far is that, yes, it is possible to derive depth information from multispectral satellite images to detect underwater objects. So this has been proven that it can be done. There are limitations, of course, and under ideal conditions, this works for water depths of up to, well, maximum 30 meters. There are exceptions where it's even where you can even look deeper. When we look at the accuracy of this data, the vertical accuracy is about 2.5 meter in 20 meter depths, which corresponds to the CATZOC Z. But if we look at the horizontal accuracy, we learned or recognized that the horizontal accuracy is much better than what we would expect from CATZOC Z. For example, if your image has a resolution of 10 meter, you can expect that the horizontal accuracy is in this range, whereas the horizontal accuracy for CATZOC Z would be about 500 meter. So this is where the idea for a concept or for shoal detection, where this all started. So we asked some questions. Can we locate shoals in underwater rocks on the basis of satellite imagery? Can we more precisely determine the position of features that are located in poor CATZOC areas? Again, in CATZOC Z, in an electronic chart, the horizontal accuracy is 500 meter. If we pick up features underwater obstructions in satellite images, can we determine this with a much better horizontal accuracy? And then if this is possible, can we use it in ECDIS? Can we use it for route planning, for alert functions? Also, a few slides earlier, I pointed out that there may be issues if point symbols are misinterpreted. So we wanted to find out if it's possible to show the real extent of features rather than just showing them as points in ECDIS. So is it possible to make hidden shoals visible to the mariner in ECDIS and mark them as stay away areas? That must be avoided. That's what we were looking into, and let's see what were the next steps. We did an analysis of some specific groundings. In July 2020, Gard P&l published an online article with the title Grounding Incidents in the Indonesian Archipelago. In this article, the author focused on the role of historical transit patterns from past voyages of the vessels, AIS data, so kind of different topic, but we still found it interesting to look into these use cases or to look into these groundings that were presented in this article. And what we wanted to find out was whether shoals, rocks, and so on were visible in the satellite images, and we could show them in an ECDIS overlay. So you must know that satellite images are stored in archives, so we can go back in time until, I don't know, maybe in the 80s, I'm not sure, but definitely we can go back in time last 5, 6, 7 years. So these groundings we were looking into, I think they all occurred about 2018, 2017, something like this. So the satellite images from that time was available. But before we go on here with our examples and these sample cases, let me take you on a short detour. So what's the road or the approach from satellite image to an ECDIS overlay? So I'm just struggling with highlighting these boxes here. So, but if we follow the sequence of steps here, there's a precondition. In order to do this, in order to be able to retrieve such information from satellite images, of course, we need areas where we have good underwater visibility. So the main factors for the visibility are the turbidity, cloud effects, and water surface effects. And the availability of suitable optical satellite data is not really an issue. I said it, there are archives where data is available for free. They go back until I don't know when, but definitely there was sufficient data for these examples. The next step then is the processing of the satellite data. That's nothing Chartworld or 7Seas can do. This is where we partner up, where we've teamed up with a company, a German company called EOMAP. They are involved in Earth observation and environmental services. There is a link on the slide to their website if you want to learn more about EOMAP. And they have the expertise to automatically derive shoals from satellite images. And they use the whole spectrum of light, which goes far beyond the visibility to the human eye. So then the next step, and that's also what EOMAP does, that these detected shoals are drawn as areas and provided to Chartworld in a suitable format, because in the end we want to make this data available in ECDIS. That's nothing what EOMAP can do. They can provide us the data in a suitable format, so we can use it to create a StayAway overlay for ECDIS. So Chartworld then converts the data into different ECDIS user chart formats. Actually, at the moment, we do support our own ECDIS, eGlobe, of course, and we also do support JRC types, JRC brands of ECDIS, and also for Wärtsilä ECDIS. Case study 1. So this was a grounding. I think it happened sometime in 2018, 19, can't recall, in the Kiramata Strait. So we did an investigation here, and what we found out is that the category zone of confidence was C, so which means that the positional accuracy of the bathymetric data is plus minus 500 meters. We did this investigation last week, so we looked at the ENCs, which were then, when we did the investigation, up to date until week 52, 2020, and at this position of the grounding, which is here, there was no isolated danger. There was an isolated danger next to this grounding position, which is shown here, but it's 1 nautical mile off. And from the satellite data, from our Stay Away layer, we discovered a shoal area like this. It's about 677 meters. It was obviously measured very accurately. I'm not saying that we can determine it to the last meter, but I would say it's definitely 670 or 700 meters. And this here, where I'm highlighting here now, this is exactly where the ship hit this rock or reef. Don't know exactly what it is. And so this kind of proves that, well, if this data had been available, maybe this grounding could have been avoided. I do not know all the details and the circumstances of this grounding, but the fact is that the ship hit this underwater obstruction. Let's continue. Go to the next case study, also grounding in Kiramata Strait. This situation is a bit different. Now the CATZOC is even B, which means the positional accuracy is plus minus 50 meters. We checked the ENCs, which were up to date until week 52, 2020, and we found that there was no isolated danger exactly at the grounding position. So there was an isolated danger here, there was one here, and there was one here. But still, the distance between this isolated danger and the grounding position was about 620 meters. So if it's not considered that this is just a point symbol which doesn't show the extent of our underwater obstruction, well, mariners may try to pass as close as possible, depending on how the route was laid out. I don't know from which side this vessel hit this shore, but this arrow indicates where the grounding occurred. Again, if this had been available, this information, maybe it could have been avoided. There's case study 3 or 4. Now we are in, actually I don't know how to pronounce it, Selat Sape, sorry for this. Maybe someone can tell me afterwards. In this area, the CATZOC again is C, which means plus minus 500 meter positional accuracy. And the ENC at the time of the grounding showed one rock only. So the only rock that was shown in the ENC was this one here, where I'm pointing with my laser pointer. The grounding occurred here. Distance here is 400 meters, and the isolated danger symbol that we see here has been inserted after the grounding. In our Stay Away overlay, the real extent of the grounding is shown. Again, if this data had been available, chances are that this grounding could have been avoided. Let's go to the last example. Again, we are in an area with CATZOC C, plus minus 500 meter position accuracy. We checked the ENCs end of last year. And we also found that the isolated danger was inserted at the grounding position, obviously after the accident. So this is where the isolated danger was inserted. This is the grounding position. I think the route was laid out something like this, or just from south. So, and it hit this obstruction, this feature, just at this edge. And what we can see in this overview, there are many more shoals we detected. So this example is from the Makassar Strait. So to be honest, it's not really fair to look at groundings and then come up with a new approach and a new technique and then just go there like, yeah, if this data had been available, grounding wouldn't have happened. So what we want to achieve is to provide this kind of information to avoid groundings. This is not a tool, or probably could be done, but our intention was not to support the analysis of the groundings with this approach or with this technique. We want to go beyond that. What we wanted to do is we wanted to use the technology to build a service for our customers, which would allow them to get this information while they are in the process of voyage planning or while they do route monitoring. So the intention is to avoid these groundings. In order to build up a worldwide service around this approach, there are a few criteria to be considered. We did a pilot project, so it was, we're not just looking into these groundings. We were selecting a specific area where we processed a lot of data to see what the results are. I will skip this. So then we could draw some conclusions, and we understood that there are various criteria we need to consider to identify suitable regions. First of all, the CATZOC distribution. So we assume that it doesn't make sense to provide such a service in areas where the category zone of confidence, where the quality of the bathymetric data is A1 or A2, which is really excellent. So we don't expect that in such areas shoals have been missed. We're pretty sure that's not the case. This is why we're not looking in such areas. Another criteria is a technical feasibility. We must admit that this technology is limited to regions where the water clarity is sufficient, so that we can really see through the water column or the cameras of the satellite. And then, of course, there's an economic aspect, the traffic density. This all involves costs, this all involves efforts. So what we're focusing on are areas where the traffic density has a certain degree, so that areas where all this comes together are the focus areas. Coming back to the feasibility, that may be of special interest. On this world map, these different color codes are used to indicate the visibility situation. For example, these magenta areas, these are areas where the visibility is 20 to 30 meter. Where we have these blue areas, it's still 10 to 20 meter. Where we have these lighter blue areas, it's 10 to 15, and so on and so on. And the red areas are areas where the visibility is limited to about 5 meters. So again, then we said, okay, which are the areas which are relevant for us, taking into account all these three criteria. So for a start, we selected an area in the Caribbean and also an area in Southeast Asia. Our friends from EOMAP, they provided us with a detailed map where within the selected areas, the visibility is considered to be sufficient. So this is these colored areas here in the Caribbean, and also these colored areas here in Southeast Asia. This is where we can expect to find shoals. We're not saying that each colored box here contains shoals, but this is where we can basically do our search and provide information and add it to our StayAway database. So how does it work from the technical side? So basically, or from the user side. So basically, the service works in the same way as all the other CIO Plus services. For those who are not so familiar, this all starts where the vessel provides us with a planned route, which is sent to the back office. This is done via Mira, or on older systems may still use chart browser. Then the back office processes the data and compares the route, the planned route, with our StayAway database. And then it returns all the StayAway areas, all the shoals that were detected in our StayAway database, and creates a data set which is tailored for a specific ship. So we do not send the entire database to an individual ship. What we do is we just tailor it to the specific route the ship sent to the ChartWorld back office. And basically, that's how it works. For those who are familiar with the other CIO Plus services, we also have TNPs, enough area warnings, and environmental warnings in our portfolio for the CIO Plus overlays. All these work as user charts for ECDIS, and I mentioned it. Currently, we do support our own eGlobe, and of course, JIC, ECDIS, and also Wärtsilä from Transas. So when you look at this at a chart without the StayAway, it looks like this. And if StayAway areas are visible, or if we found StayAway, they will be overlaid like this. So decide for yourself if this would have an influence on your decision if you would do route planning. The recommendation would always be, if you can, please avoid the StayAway areas. So this takes me to the end of the presentation. I think I mentioned it, that there will be a second part of the webinar next week. Don't want to miss that. And I think, Pavel, now we have time for some questions, and I will go through the list here. Maybe you can read out the first question.
Okay, thank you, Friedhelm. That was really interesting presentation. I think people miss me now, and I do have a few questions actually, which people asked already. I can just read one of those, and then I'll hand over to you maybe again. You can check the questions in between. So one question is it safe to be used for navigation? It's really simple answer to this, or maybe not, but the clear answer would be no, because there might be StayAway areas that you need to cross. So you need to navigate, and maybe the StayAway areas show that it's really dangerous out there. But in some cases, the mariners have a lot of experience and are familiar with the possible safety issues in that area. So of course you can actually use your knowledge and just go over that area. But for the areas where the mariners are not sure, this is really improving safety to a huge extent. So basically the main aspect here is to raise additional awareness, not really to be used for navigation, and of course not as a first tool, because here we have ECDIS and the ENCs that can be used as a first tool. So basically to raise additional awareness for the safety of navigation in this case. So I hand over back to Friedhelm.
Yes, thank you, Pavel. Yes, that's correct. When it comes to safety of navigation, you have to use your ENCs and other information. This is an additional service which provides you an additional tool to raise the mariner's attention. I'm reading out another question here. Is this StayAway service included in CIO service that we have subscribed to? I will not say who wrote this question. Of course, it can be added to the service, and we can users of CIO Plus can decide which layers they want to include in the service. So yeah, but we can follow up on this to see if it has been included already or not. Another question is coming in here. Are you saying that the ENC is not accurate and Chartworld provides updates to the relevant chart producer? Well, we're not saying that the ENC is not, or let's turn it this way, we're definitely not saying that the ENC is not accurate because whoever is responsible did a bad job. That's not what we're doing. There are limitations to how good the accuracy in ENCs can be. And we don't see this as a service that's competing to what the hydrographic offices provide by any means. And so what's the other part of the question? Chart will provide updates to the relevant. We have contacted the chart producers where we found or informed them about the service, and we encouraged them to contact us if they need more information. For example, in order to, that's interesting. Now we have the window cleaner in the background. Wow. Okay. So you cannot plan everything, but we're live. You see, we're live, right? Okay. Yeah. So we have contacted, or we're still in the process of contacting the hydrographic offices to inform them about our findings, and this is an ongoing process, of course. And so yes, again, we're not saying that anybody's doing a bad job, and what we do is much better. We see it as a complementary service. That's I guess very, very important.
Maybe I can read the next question. Sorry, maybe I can read the next question. What is the link address to the Chartworld YouTube channel? Yeah, we will provide you that over email. Basically, when the recordings are ready of all the sessions, you will have you will get a link over email of all the sessions and our YouTube channel also. So there are also some other videos that you can check over there. Might be interesting for you. Did you?
All right, let's. I should have brought my glasses. How reliable is the depth information of StayAway? Yes, maybe I have to focus on this again. So what StayAway can provide you with is not really depth information. So you can imagine StayAway as looking from the bird's eye view down to your vessel and the area in front of your vessel. And let's say you have a drone or a plane, and then you would be in contact with the vessel. And if from that perspective you could see a shoal, then you could probably warn the vessel and say, okay, there's something in front of you, 1 mile, 2 miles, very close to your route. And then you could warn the vessel. But what you could not say how deep this is exactly. You could probably say, yeah, it must be something between 5 or 30 meters, because that's what the visibility allows me to do. But with the StayAway, you cannot exactly determine the depths. We just know that it is in a specific depth range. I hope this answers the question.
Friedhelm, I think there's one more interesting question for you. The question is, this proves the value of SDB, and why not share the discrepancies with, of course, the hydrographic offices and the ENC's producers? Do we share this information with them?
Yeah, let me answer this. That's what we do. As I said, we are in contact with the hydrographic offices. We informed them about the service. We prepared actually presentations or documents showing examples. What's interesting is when we compare the StayAway layers with the ENCs, if it's overlaid in ECDIS, there are situations where both match very well, where the StayAway basically confirms what the chart says. Then there are areas where we have a kind of offset, where all of a sudden we see, there is an object in the chart, but in the StayAway, it's kind of 50 meter, 100 meter, or 200 meter off. And then there are situations where the StayAway picks up something that is not charted at all. And for all of these examples, we prepared presentations for the hydrographic officers so they can get an idea what this is. And then we encourage them to contact us if they are interested to look into this more deeply. But of course, we cannot tell them what to do. We feel obliged to inform them that we found some discrepancies, and then it's up to them how to deal with this. But we have good contacts with customers about our hydrographic offices, so they are we're getting good feedback, and they are curious to find out what we have found.
I think there's one more interesting question. Can the hazards mentioned in the incidents be detected by a passage plan safe checking? I think he refers to this being used in the ECDIS system as an overlay. Does it detect as a danger basically in the ECDIS system? I think that's the question.
Yeah, to answer this question, I can just speak for eGlobe, but I would assume that other ECDIS brands would work in a similar way. Yes, eGlobe does include this information or consider this information with respect to the alert functionality. And what we also do is, you may know that we have what is called the route network, which works in conjunction with Myra, which allows an onshore voyage planning. So we have a service which does an onshore service which does voyage planning proposal for the ships. And this is based on a route network, and this also considers the StayAway area. So the Myra service will also try to avoid the StayAway area. So this is automatically included in the voyage planning service of our customer, even if they do not have StayAway on board.
I think I have one more interesting question for you. When will the StayAway feature be technically available on board? Does the system on board need an upgrade software for the ECDIS, or the current version works directly for the customers? Can the ship staff on board apply for upgrade once received, or do we need a technician to apply for the upgrade,
Yes, very good question. Again, I can speak here for eGlobe only. I would assume that other brands deal with this in a similar way. And yes, for eGlobe customers that use CIO Plus already, or even if they don't CIO Plus, you just subscribe to the service, and this new service will work on existing eGlobe systems. You don't need a software upgrade. The reason is that it's all based on the ECDIS specific user chart format. Okay, I think we have more questions. Let me just read them, right?
Do you need your glasses, or I can read it for you?
You can. I can read it. No, I can just give me a second here. There's
okay.
Another one. Yeah, I think that's part of the previous question. When will the StayAway area features be technically available on board?
No, that was the same one that we already answered.
Yeah, that was the same one. I can see just on the first and second part here. So
yeah, go to the next one.
Yeah, officially it's not used for navigation, but de facto it is. For instance, by generation of warnings. Maybe that's the second part of a previous question. I would have to go to this. Yeah, there are some comments regarding sharing this data, so that HOs can just pick it up somewhere. I think, yeah, that's an interesting suggestion, but probably there are also license issues with it that we probably would have to clarify before we could just go and share this data, because we have licensed the source data, of course. So, but that's an interesting aspect. So the suggestion here is that the data could be provided as crowdsourced bathymetry, if that's possible, so that all the hydrographic officers would have immediate access, and other users probably as well. Interesting point, but yeah, maybe we can elaborate on this more after the session here.
Yeah, maybe you can add up something to the last question. It says officially it's not used for navigation, but it is used in some way. That's kind of a fact. Yeah, it's more a legal thing because it's still kind of unofficial data. You still need to follow the official data. And this is, again, just maybe adding up to the first question. Additional awareness. It cannot be really official data for navigation. Not at this point. Maybe at some point in the future, this will be something that will be officially used for navigation, but not at this point. It's a legal thing, I would say more. Maybe the next question, what is the expected cost of StayAway tool? Do we have answer to that, or they can refer to the sales department maybe regarding this?
Yeah, of course. I think it's definitely affordable, but yeah, we're not. This is, I would hand over to the sales department. And yeah, Pavel, are we